ladies and gentlemen.
So let's talk quadrilaterals. Quadrilateral is a four-sided shape. It's closed, no overlaps. What do I mean by that? You can't have an hourglass shape. If I could draw that with four straight lines, and I connected it and made it look nice, that would be four straight lines connected. But it's overlapping, so it doesn't count. Also, it has to be closed, so I can't just draw four random lines that touch one of the lines but don't fully connect to each other. Once I have that, then I'm golden. A fact that is true about all quadrilaterals is that all of their interior angles sum to sum to 360 degrees. That is wrong. 360 degrees. I made a typo. Oh well, we'll rock with it. Let's solve a question then. So in a quadrilateral ABCD, what is the value of x? So we have three angles, we're missing a fourth, and the sum of all of the interior angles is 360 degrees. So we're just going to add all of these together. So I have 70 plus 130, which is 200, plus the 100 from B gives me 300. So I have 360 degrees to use. I've used 300, so 360 minus 300 gives me 60 left, so x is equal to 60 degrees. Not too bad, right? Now, let's talk about some special quadrilaterals. So some quadrilaterals have, special properties about them, and we'll discuss. The first one is a parallelogram. So a parallelogram is a quadrilateral, fits all of the definitions of quadrilateral. In addition, its opposite sides are parallel. So this side here and this side here would be parallel, and this side here and this side here would be parallel. What does that give us? That gives us that the opposite angles have the same measure. So whatever this is going to be the same over here. Whatever this is going to be the same over here. Opposite sides have the same length. So if this is B, this has to be B as well. If this is A, this has to be A as well. And that the adjacent angles, the angles that are not across from each other, in this case x and y, must sum to 180 degrees. They are supplementary. In addition, we have rectangles. So rectangles are a special type of parallelogram. In addition to the opposite sides being parallel, the angles are all right angles. They're all 90 degrees. The only additional thing that this gives us, besides the 90-degree angles, is that the diagonals, if I connect opposite vertice to opposite vertice and opposite vertice to opposite vertice, that those two lines are the exact same length. That's the only additional thing I get from rectangles that is overly useful. The last one we're going to talk about is a square. And a square is a special rectangle, so it fits all of the classifications of a rectangle, which fits all the qualifications of a parallelogram, which fits all of the classifications of a quadrilateral. And what makes a square unique, the one thing that it gets above everything else, is one, the sides are all the same length, that's part of the definition, but also the diagonals that we drew before all have a specific length. They are root 2 times larger than the actual side length of the square. And we kind of discussed that in our 45-90 video of why that is, but that's the only really extra thing you get from a square besides knowing that all of the sides are the same length and all the angles are 90 degrees, which are part of its definition. That is it for quadrilaterals. If you have any questions, please let me know. And there are more quadrilaterals. If you want to talk about them, we can discuss them in the comments. But they're not quite as common on a lot of your things that you're going to see in like pre-calculus, calculus, or a standardized assessment. So we can talk about them in the comments if you want, but we don't really need them for this video. But if you have any questions, let me know. Otherwise, I look forward to seeing you in the next video.